Hello everyone, this is Mrs. Klusek. I'll be explaining the first page of the Lesson 13-8 notes on reciprocal trig functions. We're going to start with our basic SOHCAHTOA. So for a sine function, which is the opposite over the hypotenuse, cosine, which is a trigonometric function that's defined as the adjacent leg over the hypotenuse, and the tangent, which is the opposite over adjacent. This should be review. Now here comes our new trig functions, which are the reciprocal trig functions. Cosecant is the reciprocal of sine, so I take the fraction and I flip it around, so the hypotenuse comes to the numerator and the opposite goes to the denominator. The secant is the reciprocal of cosine, so that becomes h hypotenuse over a, and cotangent is the reciprocal of tangent, which is a over o. Cotangent is the reciprocal of tangent, but cosecant is the reciprocal of sine. You might want cosecant to go with cosine, but they don't go together. All right, for our first example, we're going to take and label the right triangle pieces. 8 is the leg that's opposite, 15 is the leg that's adjacent, and we know 17, the longest piece, is the hypotenuse. Sine is defined as opposite over hypotenuse, so I'm going to make that 8 over 17. Then I'm going to take those two numbers and flip them around to get the cosecant as 17 over 8. For the cosine, the adjacent leg over the hypotenuse is 15 over 17. And the secant is the reciprocal of that, so I'll just take that fraction and flip it around, leave it in proper. And for tangent, I'm going to take the opposite, which is 8, over the adjacent, which is 15, and flip that fraction around for the cotangent. It's just that easy. All right, my next example. Be careful when you label your pieces. You can see the hypotenuse is this 21. It's the longest piece across from the right angle. For this 7 leg, we're going to label that opposite to theta and adjacent for the 14 root 2. Sine is defined as opposite over hypotenuse, so that's going to give me 7 over 21. Both numbers can divide by 7, making 1 over 3. Cosine is defined as adjacent over hypotenuse, so that's going to give me 14 root 2 over 21. Divide 14 and 21 both by 7, giving me 2 root 2 over 3. Now I'm going to do the tangent. The tangent's going to give me the opposite over the adjacent, which is 7 over 14 root 2. Not only do I have to reduce this one, but I also have to rationalize. 7 goes into itself once, 7 goes into 14 twice, and then I need to multiply by root 2 over root 2. That's going to give me square root of 2 in the numerator, and then this 2 gets multiplied by this 2, because 2 times 2 is 4. 4 square rooted is 2, so that's going to make 4 in the denominator. Okay, now I'm going to take the reciprocal of tangent, which is cotangent, so I'm going to take the original one, the 14 root 2, and the 7, and I'm going to reduce this. I don't need to rationalize because the square root is not in the denominator. So that's going to make 2 root 2. And then for secant, be careful now, secant goes with cosine. So I can take the reduced one up here and flip it around. But then I need to rationalize by multiplying by root 2 over root 2. That's going to give me 3 root 2 over 4. And last one, cosecant is a reciprocal of sine. So I can just take this 3 over 1 and reduce it. Hope that makes sense. Have a good day.